Assalamualaikum, my name is Muhammad Qayyum bin Isa. Today I'm going to talk about introduction. Bandpass filter was invented in 1930 by a British engineer and physicist named Stephen Butterworth. He talked about this bandpass filter in his On the Theory of Filter Amplifier. There's actually inductor, capacitor, reactive element used in the filter, but in the case of Butterworth, filter only capacitor are used. So basically the number of capacitor will be decide the order of filter. The meaning of band pass filter is arrangement of electronic components that allow only those electric waves lying within a certain range or band of frequencies to pass and block all other. In simple words, this method is allow signal to pass between two frequencies by a device or an electronic circuit. Also, the reason why it is called the bandpass filter are because there are two reactive components within their circuit design. The reactive component, which is the capacitor that placed in the low circuit, and one at the high pass circuit. The bandpass circuit used for screen out frequencies that are too low or too high. So base frequency within a certain range by giving easy passage. Moreover, sticking a low pass filter on the end of a high pass filter or the other way around and how band pass filter made. Hence, this method are widely used in wireless transmitter and receiver. A simple passive band filter can be made by considering together a single low pass filter with a high pass filter. So this is the example of the circuit. There are high pass and low pass.
Okay, so next is the methodology of the project. Okay, the methodology is by the first part is the data collection. Next is circuit designing. Third is circuit drawing and simulation, and finally the analysis of circuit. Okay, for the data collection, data is collected via multiple sources such as our textbook or the internet, and to be used as reference for answering the question of this project. Okay, next for the circuit designing, we choose our project to be an bandpass filter circuit. Okay, so which in consideration of the value of operational amplifier, filter capacitor, resistor and input voltage. For the third part is circuit drawing and simulation. Okay, this is our chosen circuit, bandpass filter circuit, and the circuit design and simulation is made by using the software named NI Multisim. Okay, it's an easy software to use with a wide variety of functions with the complete list of components to use. Okay, so next is the last part, which is the analysis of the circuit. Okay, the study of the circuit based on the performance of the simulation is carried out in order to show the output of the bandpass filter circuit frequency. A frequency response graph is used for the output frequency. Finally, circuit analysis is carried out based on the simulation performance, when the function of the components involved in the circuit is discussed, as well as the resonant frequency and output frequency bandwidth, and determined using an appropriate formula from the output frequency response graph for the Q factor. Okay, so next.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farhan Najmi bin Kamaruddin with matrix number AN200034. For result and discussion, 3.1 simulated signal, the circuit that we use is passive band pass filter circuit. which the left side is the high pass filter stage and the right side is the low pass filter stage. At the left side, we see that we use 1 volt and 1 kilohertz of voltage and 15 and of capacitance and 10 kilo ohms of resistance. At the right side, we use 10 kilo ohm of resistance and 60p of capacitance. For the input signal characteristic, we see that this is sinusoidal wave that we got from the circuit above. And then from the circuit, we can get the amplitude of the waveform is set to 1 volt peak of voltage and 1 kilohertz of the value frequency. So for 3.3, waveform cut off frequency low. So for the frequency low at the 3.436 dB, we get 1 kilohertz. And for the frequency high, we get 31.623 kilohertz at negative 3.6538 dB. Okay, so for the whole diagram, we get this shape. This is our shape for the band pass filter output signal characteristic. So we get that from the above, we get that high RC component will be used to build second order band pass filter that will allow frequency above 1 kHz and below 30 Hz to pass. The filter will have a peak response or resonant frequency FR as a result of the two reactive components. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad bin Azlan. Saya akan membentangkan tentang calculation. Untuk calculation, kita akan mencari frekuensi high, frekuensi low, resonant frequency, bandwidth dan quality factor. Untuk frekuensi high dan frekuensi low, kita akan menggunakan 1/2 pi RC. C untuk frekuensi high, kita dapat 15 nanofarad dan R 10 kilo ohm. Kita akan masukkan nilai tersebut ke dalam formula iaitu 1/2 pi kali 10k kali 15n. Kita dapat nilai dia ialah 1061.03 Hz. Seterusnya frekuensi low. C dia 560 picofarad dan resisten ialah 10 kilo ohm. Dan kita masukkan menjadi 1/2 pi kali 10k kali 560p. Dan nilai dia 28.42 kHz. Seterusnya resonant frequency. Resonant frequency ni kita akan menggunakan formula ni iaitu set frekuensi high kali frekuensi low. Kita akan masukkan nilai frekuensi high dan frekuensi low dan kita akan mendapat jawapannya ialah 5.491 kHz. Seterusnya untuk mencari bandwidth kita akan menggunakan formula frekuensi high minus dengan frekuensi low iaitu 1061.03 minus 28.42k dan nilai dia kita dapat minus 27.36 kHz. Last sekali untuk mencari quality factor, formula dia ialah FR per bandwidth. Kita akan masuk nilai dia dan jawapannya ialah minus 0.2. Okey, itu sahaja daripada saya. Sekian, terima kasih.
Hi, now I'm going to present about our conclusion from this project. In our project, we use 1 voltage as input. We got 1 kHz as input frequency and 5.491 kHz as well for output frequency. When we run the circuit in the diagram above, the value for high pass filter with lower cut-off frequency is 1 kHz. The value for low pass filter with higher cut-off frequency is 31.623 kHz. The resonance frequency is 33.55 kHz. Next, we get the value of negative 27.36 kHz for the bandwidth. Finally, for the quality factor, we get the value of 0.2.